everyone, my name is Nathaniel, and in the previous video we talked about atomic structure. But in this video we are going to be talking about chemical union and chemical structure, or for short we'll just simply talk about chemical bonds. Now, without wasting much time, let's delve into the matter. Today we'll be dealing with ionic bond or electrovalent bond, covalent bond, coordinate or dative bond. We're talking about metallic bonds. We're talking about shape of molecules, of some selected molecules. We'll also talk about allotropes. So join me as we dig into this tasty meal of chemistry. So now after studying the properties of atoms, we also know that atoms combined together in different forms. That was if you remember in the previous episode, from the first episode or the second episode, I stated that was John Dalton's theory. That's the fifth theory, where he stated that chemical combinations and chemical separation of atoms result in chemical reactions. So that means all these reactions combined from are gotten from the combination or separation of atoms. So basically, that's where we have ionic, covalent, coordinate, and metallic and shape of bonds. So basically, these different types of bonds, they are formed when an atom combines with another atom. So, and that is called a bond. A bond is basically a connection between two chemical substances or chemical entities. So now, in ionic bond or electrovalent bond, we have to talk about the fact that these two atoms that have been bonded, they are transferring electrons. So ionic bond or electrovalent bond simply involves the transfer of electrons, and it is always from the positive or the metal to the non-metal. It's often from the metal. Metals are often electron donors, and non-metals are electron acceptors. So let me give an example now. There's a compound called magnesium oxide. It's called MgO. Now in this compound, magnesium on the periodic table is the 12th element, or having a atomic number of 12 and mass number of 24. Then oxygen is the 8th element, having an atomic number of 8 and mass number of 16. Now if we draw the electrovalent configuration, now let me teach you how to draw the electrovalent configuration. Now this is in terms of the electron shells. So basically you just draw the nucleus, as we talked about in the earlier video. Nucleus is the dense part of the atom. So you draw the shells. We have in increasing proximity, in order of proximity from the in order of distance from the nucleus, we have different shells, and K, L, M, N, O, and so on and so forth. So K is the closest, followed by L, followed by M, followed by N, and so on and so forth. So this is the first shell, K shell. K shell will take only a maximum of 2 electrons, 1 and 2. And if you are wondering why that is so, the formula for getting the maximum number of electrons in a shell is given by 2n raised power 2. So that means where n is the orbital number of the shell. For example, K is the first one. Just put that number 1. That's 2 times 1 raised power 1. 1 raised power 2. That's 2 times 1. That's 2. So for the L shell, you can say 2 times 2 raised power 2. That will be 2 times 4. That's 8. So that means for this next shell, we'll be having a maximum of 8 electrons. So to run the shell, let's put 2 in pairs, lone pairs, 1, 2, 3, 4, 5, 6, 7, 8. So far there are 12 electrons in magnesium electronic configuration, but we've had only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So remaining 2. So let's do the last shell. That will be the M shell. So this M shell is not completely filled. That's one lone pair of electrons. So now, and then we have the oxygen atom. This oxygen has the nucleus, then the K shell, which will take 2 electrons, then the M shell will take 8. But since oxygen does not have up to 8, there will be only 6 in the M shell. In the L shell, sorry. So now basically all the electrons here are 2, 4, 6, and 8, right? So that means now in electrovalent or ionic combination, what that means is that what we are going to do is we are going to move the electrons from the electron donor to the electron acceptor. And just in case of reference, it's good for you to know that electron donors are always metals and electron acceptors are always non-metals. So the metal here is magnesium, and then the non-metal here is oxygen. So that means we are going to move 2 electrons from the magnesium's M shell, that's the valence shell, and the valence shell is basically defined as the outermost shell. So I want to take these 2 electrons they are going to be transferred to the oxygen. And the reason for that is that every element is striving to achieve a stable octet structure or duet structure, just like this. So the reason why oxygen is taking 2 electrons from magnesium is because it wants its outermost electrons to be filled. It wants its outermost shell to be filled. So when we transfer this to this side, so you can see that in this case, magnesium has lost 2 outermost electrons from its valence shell, and so this valence shell will disappear, and then its L shell will be filled, but its M shell is discarded away, and then this oxygen now has its shells filled. So now this forms a kind of electrical bond between the two. So this ionic bond is basically an electrical bond that forms when we have anions and cations. So basically what this happens is that when this magnesium loses 2 electrons, it becomes a positive ion. That means it's positive by 2 charges. That's Md2 plus will combine with oxygen O 2 minus. So this is the equation of the reaction. So the magnesium cation with a positive charge of 2 and the oxygen anion with a negative charge of 2 will combine together to form magnesium oxide. Then we also have covalent bonds. Covalent bonds are formed when we have 2 elements coming to share electrons. For example, for the same oxygen, if oxygen combines with another oxygen atom like this, if there's another oxygen atom like this, then we have 2 in the 2 at the L shell. So you have 6 in the L shell. Now for these oxygen atoms to be filled, they will come together, and instead of transferring their electrons, they will share the electrons. And this occurs because the electrons in a covalent bond, they are not enough to transfer, so they can only be shared. So what that means is that oxygen will bring 2 of its electrons to be shared, as in here. Let me adjust the position. So oxygen will bring 2 of its electrons like this. So it has brought these 2. The first oxygen atom, then the second one too will also bring 2 of the electrons here. And then the number of electron pairs that are shared is called the bond. For example, there are 2 electron pairs shared here. So this is the bond of the bond in oxygen is 2. So, but each of the oxygen atoms also has 2 lone pair of electrons at the L shell, and then the oxygen, the second and the first, they both have 2 lone pair of electrons at the L shell. But then the L shell is filled because of the covalent bond. So and then we also have coordinate covalent bond or dative bond. And the coordinate covalent bond is like a branch of covalent bond, in that the electrons are also shared, but in this case only one atom is providing the electrons. An example of compound that exhibits that is ammonia, NH4. So when ammonia combines with hydrogen, it forms ammonium ion. That's the ammonium ion. NH3 combines with hydrogen, it forms the ammonium ion. And this ammonium ion is formed when this hydrogen also loses its electrons. So there is a transfer. Only one atom is donating the electrons. So yeah. Okay, that's for coordinate bond. And then we have metallic bond. Metallic bond is a type of bond that is formed between metals. So and then basically that involves when the metals have electrons, because you know that metals have excess of electrons which they like to give away. So and when that electrons are within the atoms of the metal, those electrons begin to circulate from one atom to another, and that forms a metallic bond. So that is a metallic bond is formed basically from the circulation of electrons in the atomic orbital. Then after that we have the shape of orbitals. The shape of orbitals. Now each of these bonds, they have their different shapes. For example, carbon dioxide has a linear shape because it's formed when we have a carbon atom and 2 oxygen atoms are bonded to that carbon atom. So and then it's a double bond between the carbon and either of the oxygen atoms. So it's a double bond between them. So let me magnify that. So you can see the bond between carbon. It's a double bond between carbon and oxygen. So that is how it is. Then moving on, we have ammonia. So that means this carbon dioxide has a linear shape. Then we also have ammonia. Ammonia also has a trigonal shape. So it has trigonal planar shape, and it has a bond angle of 120 degrees. That's for ammonia. Then CO2, carbon dioxide, has a bond angle of 180 degrees. Then we also have water. Water has a bond. Or rather steam. Steam has a bond angle of 104.5 degrees. So and steam has a V shape. So and that is basically the shape of atoms. Then lastly, for this video, I'll talk about allotropes and allotropy. Allotropy and allotropy simply means the fact that the same elements have different physical forms in the same physical state. So, for example, carbon has two allotropes called diamond and graphite, and sulfur has two allotropes called rhombic sulfur and monoclinic sulfur. Then, for example, phosphorus also has two allotropes, red phosphorus and white phosphorus, and the white phosphorus is highly poisonous. So basically, those allotropes. Basically, the phenomenon whereby we have the substance or the matter, for example, carbon, has different two different form in the same physical state. So in summary, we've talked about ionic, covalent, coordinate, metallic bond. We've talked about the shape of CO2 as linear, the shape of ammonia as trigonal planar, the shape of water as a V shape, and angle of 1 and 4.5 degree. Then we talked about allotropes and all the rest. So thank you for watching.